Hmm. Who? Okay.
Am I on?
Hey, Anaya. Yeah, I got you. You're here.
Hello.
Okay. How you doing?
Good, I guess. I just did a presentation for my other class.
Just did what?
Presentation for my other class
Oh,
before this.
okay. Well, that means it's over with, right?
Yeah, so I had to wake up earlier.
Yeah. Okay. Haley, are you there? Yeah. Yep. I see you. Okay. I got Bree, but I got no video with Bree or Tori yet. Haley, I just sent you something back. Did you get it? Did you get what I
Uh,
said about the quiz?
not talking about this morning.
Yeah, I sent it back this morning. It was that
Oh yeah, I got the anti or
Mm,
the applications of the
yes.
anti-derivatives.
Yeah. You
Yeah.
just made one careless little error in the end there. Okay. That's the one I
And
told
then
everybody.
I sent you the redo of the other problems last
Yeah.
night.
Yeah. I saw those. Okay. That was good.
I don't know if they were right or not.
They were all, you finished them up all right. So they were fine.
Okay.
You sent me the remainder of it. So I changed everything. Okay.
Is it okay if I send in my quiz like a little bit after this meeting's over?
I'm getting ready. I'm going to go over it. That's the first thing I'm going to do. And I really need to talk to everybody about that one today. So just listen to me and let me see. Hang on one second. Look at something. You got enough to drop a couple of quizzes, so don't worry about it. Okay, just listen to me today. Okay.
Okay.
Okay. That'll help you more on the test, and that'll be where it's important, I think. Okay. Okay. So, Bree, can you hear me? You there, Bree?
I'm here.
Bree. Okay, Bree. Okay, good. Tori, you hear me? You with me?
Yes.
Okay. All right. Good. Guys, I don't want to waste a lot of time today, so let me tell you what I'm going to do first. I've sort of tried to work everything out that we've been working on lately, and then I want to go back and look at that test review. So let me share the screen and we'll talk about what we've done on these last couple of quizzes. It seems a little rushed. I'm getting things in all along, but let's just go over it, make sure everybody understands the basic ideas. Okay, so I even do that one. Okay, so the one before the very last one, that is the one that that didn't have those definite integrals on it, was sort of the applications of the antiderivative, and this was one of those quizzes. I want to go over it. I want to talk about the fact that everything we've been focusing on for the last week or so are these antiderivatives, and we got a power rule for them where you added one and put it over those. We were careful to put a plus c on it because we knew a lot of functions could have that same derivative because the derivative of a constant is 0. So anytime you're given something that says here's f prime, find f, you're going from a derivative to the function. So you're going to have to take an antiderivative. So what I wrote out in this one was the antiderivative. I want to find f of x. I'm going to take the antiderivative of this thing right here. Now I wrote it all out, guys, so I wouldn't have to waste time doing that. But there it is right there. So I'm taking the antiderivative of that. Power rule says add 1 and put it over that. So 2 plus 1 was 3. So 4x cubed over 3. Antiderivative of a constant is that constant times x, or whatever your variable is. Then we add the plus c. Okay, so if I add plus c, that just means I've almost got the answer there, but I need to be able to find out what that c is. And the information that tells me what that c is going to be is this little piece right here. It says if you plug in 3 for the function, in other words, if you let x be 3, the function is going to be 0. So f of x will be 0. That'll allow me to find c. So that's exactly what I did here, and it's exactly what I'm going to do for every one of these problems. This is just a generic one. It didn't have cost or profit in it, but they all work the same way. So I'm going to plug in 3 for x into my antiderivative. I'm going to crank that out. I got c is -9. So my final answer is the function that you found with the c that you found. And it's this thing right here. So there's the answer. Please stop me if you don't see what I did, but I did all the legwork here, and you can verify the numbers. I think they're okay. So that's what I did there. Now, how does that apply to anything we would want to do? That's what the next few problems are about. And I want to emphasize they're exactly the same, except they're now couched in this applications thing. One of the big ideas we had over the semester was that marginal profit, marginal cost, marginal anything is a derivative. So in this second one, the marginal profit is given by this function, and it says the profit at 5 is 650. This is the same as that last problem. As I said, look at what you're asked to do. You're asked to find the profit. You see P prime, that's a derivative, and you want to go back and find the profit, you need an antiderivative. So I took this thing right here. I took the antiderivative, used the chain rule. I mean, not the chain rule, the power rule. So it's 40x squared over 2. That's a 1 right there, so I'm adding 1. The integral of any constant is just that constant times the variable. So 250 times x plus c. Once again, that's what we called an indefinite integral. It was a family of curves, if you remember. But I'm given something here. I'm given that the profit at 5 is 650. So I'm in my own way here. So I'll take what I've got right here, this thing right here. That's the generic. I sort of got halfway through the problem. But now that little point right there tells me that if you plug 5 into that, so 2 into -40 is -20, guys. That's where I got that. Plug 5 into it, 5 squared plus 250 times 5 plus c, you will get 650. Notice you got just a string of numbers with the c is the only thing you left to find. Crank out all those numbers, isolate c, we got c is -100. Put that on to the thing you found, the profit. In other words, I've now found the c that I wanted right there. There's the profit function. Once you get the profit function, you answer the question, what's the profit at 10? Plug in 10. -20 times 10 squared plus 250 times 10 minus 100. So it's the profit there is $400 or whatever we're measuring in. Is everybody okay on that? This is I'm doing like 3 of these things in a row. It's the same thing. You got the derivative. You want to find the function. You got to go backwards. You got to find the antiderivative. You got a point. You can plug it in. You can find what c is. Everybody okay on those first 2? All right, you got to talk to me today because I want to be grading some good tests this weekend or next week, whenever they're due. All right, look at 3. 3 says, find the cost function if marginal cost is this. Notice that, you see a c prime. So you're given the derivative, you want to find where it came from. You want to find the cost. Anti-differentiate, we call it integrate. Use the power rule, x to the 1 plus 1 is x squared over that thing 2, plus the integral of any constant, is that constant times x, plus c. I simplified it a little bit. They told me that the fixed cost is 1,000. All right, in other words, at 0, fixed cost means what I have to lay out before I can even make any money. The fixed costs are 0, so I'll plug in a 0. I'll plug in a 0 right here, and I'll get a fixed cost of 1,000. So C is 1,000. So your actual final answer here is C equal 0.01x squared plus 10x plus 1,000. I did the same thing in every one of those problems. I anti-differentiated, and then I plugged in the point to find out what C was. Somebody, yeah, there we go. Jennifer's in now. Okay. All right. So, Jennifer, if you just came in and you can't, if you can hear me, I'm just going over one of these quizzes that we had. Okay. Now we went on from these indefinite integrals to talk about the last thing we're going to do, and that was a definite integral. It's not much harder, and the applications are brief. Okay, we've got just a couple of applications to go with it. When I have these numbers on an integral, it's called the definite integral. But the first step that I always do is just take the antiderivative here. Take the integral. Pretend these things weren't here, okay? If I use my power function then, and by the way, once you take the antiderivative, don't put these integral signs anymore, all right? Don't put integral equal. You've done it. Just leave it. You don't have to write it again. So this will be 2 x to the 4th over 4 minus x squared over 2, because that's a power 1. The integral of a constant is just that constant times that. So I'm not going to add the plus c here because you're going to see it's going to go away no matter what it is. But once I find the antiderivative, I'm going to do this. I'm going to put a bracket there and put the limits on these things. This 3 is what we call the upper limit, and the 1 is the lower limit.
So you know how on my quiz you circled the 1/2 x to the 4th? Can you not simplify the 2x to the 4th over 4 to that?
Yeah, it should have been 1/2, but I think you put 2/3 there. I think it was you had a careless error when you were writing that, Haley.
Well, I put 1/2, but then on the second step when I plugged in the limits, I put minus 1/2.
Okay, that was right. Let me play it out and see. I thought I saw a careless error there, but I may not have. Let me play it out and see if we get the same thing. Okay.
Okay.
Okay. I was trying to do that this morning and get it out kind of fast since we were getting ready to have class. All right. What I do at this point is I plug in that upper limit first. And actually, Haley's right. It's probably not a bad idea to simplify this, so it'll be x to the 4th over 2, because 2/4 is 1/2. So x to the 4th over 2 minus x squared over 2 plus x, and I'm going to evaluate it from what we say 1 to 3. Let's see if I got that right. Okay, that looks good. Then what I do is I plug in the upper limit first, so 3 to the 4th over 2 minus 3 squared over 2 plus 3. Now I finished plugging in the upper limit. Now I'm going to take away, in parentheses, the lower limit plugged in.
Did she freeze?
Am I frozen? Can y'all hear me?
I think she did.
Okay, wait a minute. Let me see what's going on.